lab 2 of Crew AI, and we are going to understand the agent class within Crew AI, which is one of its core building block. Now, agents are at the heart of Crew AI. It's a specialized worker we configure with a role, a goal, and a backstory, and then enable it with a language model and set of tools. Right? So in this lab, we will walk through every attribute of the agent class, and then we'll create an agent. Right? Now, as I was telling that a agent is a autonomous unit. It's one of the first class object in Crew AI that performs the work on your behalf. There are three required attributes, which is the role, which defines the persona of the agent, the goal, which uh, defines what the agent needs to achieve, and this is what steers its decisions. Backstory is the personality and the context that we ground the agent to, so that it is grounded to the tone and approach of the work that is given to it. The LLM is at the core of the agent, which powers its reasoning capability. The tools give it access to the external data and compute. Right now, the attributes we spoke about: role, goal, backstory. There are many other attributes which are optional. Let's go through them. So LLM, through the LLM attribute, we configure the agent with a language model. If we don't give it, it defaults to the model from the environment. If I want a separate LLM to do the tool function calling, I can do it using the function calling LLM attribute. Tools attribute allows me to configure the tools the agent has access to. Through this, I can reduce the decision boundary of the agent, right, by giving it very work focused tools instead of giving it access to a number of tools. Right, max iteration is the maximum number of reasoning iterations the agent can do before it can answer a question. Right, so the max iteration, again, you are doing a bounded compute. Max RPM is the maximum request per minute. So if there are any rate limits that we are aware of, right, we can use the maximum request per minute to respect the rate limits. Maximum execution time, how much time an agent can execute before it fails or it gives away. Right? Maximum retry limit, if there is a defect, or sorry, if there is an error that happens in the code, let's say it's a 429 error, right? Max retry limit will give you the number of retries that the agent can do. Through the memory parameter or the attribute, we can enable the agent with a memory so that it retains the memory of the interactions. When we say respect context window, when we enable this attribute, it auto summarizes the messages in the context window so that the model's context window is not bloated, or it doesn't, the context doesn't grow beyond the size of the context window. Reasoning, when we mark it true, the agent plans before executing. The maximum reasoning attempts, how many, it's a cap on how many planning attempts can be made before it can actually do the planning and the execution. Right, multimodal enables processing of images alongside text. Allow delegation, if we enable it, then the agent can delegate to its teammates, otherwise not. Allow code execution mode. Through this, we allow the agent to run code. Inject date and date format attributes injects the current date in a specific format that we want into the context window. Cache, the tool results can be cached so that every time it doesn't have to use the every time it doesn't have to determine the tool call description and the tool call. It can avoid the redundant calls if the tool results are cached. It doesn't have to call the tool every time. Right, if the same tool is used multiple times within the application. Verbose, if we say verbose true, then it prints the detailed execution logs. Step callback is again a important attribute. After every step, I can have a step callback if I want to log very specific log metrics for a particular step, or do something after the step is completed. I can use it using step callback. Knowledge sources, the knowledge sources the agent can draw on. Embedder, the embedding configuration for retrieving memory, storing memory, retrieving knowledge, right? System template, prompt template, response template, if I want to customize the prompt templating for even better or full control over the system, user and the response prompts. The use system prompt, I can disable or enable it based on, let's say, if some LLM does not have a system prompt type of configuration, I can disable it, right? And this is how we instantiate an agent, right? We import the agent from CrewAI, and this is how we create the agent. So we'll do the lab now, where we'll create the agent using code. Earlier we saw how to create it using YAML. Now we'll, in our lab, let's go to the lab and create a research agent using the code. Basically, we use code to create the agent. Let me go to my PyCharm, new directory. Let's create a research agent directory, and I'll say research agent crew Python file, right? And then let's copy this code. So what we are doing here is we are importing the agent from the CrewAI class. I'm creating the agent here, giving it a role, goal, backstory. I'm not going to use this. I'll want to use Anthropic, and the model Claude Opus 4.8 is what we'll use, right? Verbose equal to 2, true, right? And let's see if what happens. So I'm going analyst.kickoff, explain what an AI agent is in 2 sentences. Execute it. Yep, it started executing it. Oops. So, okay. In progress, started. This is the final answer, right? It completed, right? So this is how I can do an agent. Now, if I want to create a structured output, I can have a Pydantic class. Let me put this Pydantic class here, right? And import the base model. I think it is Pydantic, yes. And I can give it a response format, which is the Pydantic class. So it is in the result equal to analyst.kickoff. Okay. And now when I run it, I should be, so we have this definition, right? Definition and example, right? Okay, so this is the definition, right? It gave me the definition, and there should be an example. This is the example, right? Right, so this is how we can do the structured output with agents. So that completes our lab 2. I will now start with the lab 3. Thank you.